As I mentioned before, both the Indian and Atlantic Oceans also have a zonal mode of variability, which is El Nino-like, so east-west mode of variability. Both the oceans in their zonal extent in the deep tropics are much shorter than the Pacific, and corresponding to that, the wave travel time will be much shorter, and the mean conditions are different as well. So both of them have a El Nino that only lasts in its peak phase for a season. So the whole life cycle is much shorter, and in the Indian Ocean it's called the Indian Ocean Dipole. There's a lot of debate about whether it's really a dipole or it's a monopole, and whether it's related to El Nino or not, and so on and so forth, which we won't get into. But the 1997 event, which accompanied the big El Nino of 97-98 in the Pacific, brought this back to attention, even though it was noticed in 1961 and also happened in 1994, and now it's studied a lot. And we can start by looking at the sea surface temperature anomaly for November 1997, and you can see a strong cooling over here with this horseshoe pattern on the other side, which is kind of very similar to the El Nino pattern we get, let's say, during a La Nina. But during an El Nino, of course, the Pacific has warm SSTs here and cold SSTs on this side. In the Indian Ocean, if you remember, this is part of the Indo-Pacific warm pool, and cold temperatures are on this side, so it has a different structure than the Atlantic and Pacific Oceans. So the positive Indian Ocean dipole is here when the cooling happens here, and then there are issues about whether this also includes the Bjerknes feedback, whether this needs a trigger, and why it is so episodic, and so on and so forth. Okay, it is not at all as frequent as El Nino, and it's unclear still whether it is completely independent of El Nino or not. So the book says that we can basically assume that it's independent of El Nino, but this debate continues, which I will come back to in a minute. So this is the delta OLR, reduced rainfall on this season, but you can see that the rainfall here is complicated because the it's not a Walker cell in that sense of the Pacific, where you have West Pacific convection, East Pacific getting the convection and drying up, but here you have a complicated relation with the monsoon. In fact, 97-98 was a very strong El Nino. You would expect a strong drought over India, but India had basically normal monsoons, because there is some debate that maybe this prevented the drought. But one has to still wonder whether this happens in September, October, November. The monsoon happens in June, July, August, September. So who's influencing who? And it's the same for El Nino impact as well. El Nino peaks in December, January, February, but the monsoon peaks 6 months before in June, July, August. So how does the El Nino affect the monsoon? And to go with that, we know that only 50% of the dry and wet years over the Indian monsoon can be explained by the El Nino. Other 50% are potentially related to the Atlantic or other forcings from elsewhere, or what is called internal variability. So the monsoon generates its own droughts and floods. So this is the zonal wind anomaly, obviously associated with this upwelling. There's a very strong easterly anomaly that you can see here, and the sea surface height has a peculiar structure because the Indian Ocean has a wind stress curl here, the westerlies we saw when we saw the ITCZ. So this is a region with a very shallow thermocline. So this ridge, so-called thermocline ridge here, shows up as a sea level signal associated with the negative sea level signal over here. So definitely there is a east-west mode, but lots of differences from El Nino and lots of unknowns, just like El Nino, and even more. So this is the evolution from January 1. You can see that there is just some noisy anomalies, regional local anomalies, and then it begins to get organized and sun gets set during September, October, November, and then almost abruptly disappears, and the warming is already started here. So this is a question: is it really a dipole? Because then it becomes a monopole here, which is a common pattern associated with El Nino, and what triggers this, whether this is really independent of El Nino, and so on. And this is the zonal wind anomalies associated with that. So again, there are lots and lots of papers, and many fundamental questions still remain open. So this is talking about association of IOD with ENSO, looks at the dipole mode index, which is the sea surface temperature anomaly differences between the east and west, and looking at Nino 3. If you just look at annual correlations, the correlation is rather low. But if you look at correlations in SON when the IOD happens, then the correlation is quite significant. And there is a correlation with the OND rainfall over Kenya. So the idea is, in this argument, it says that El Nino correlation is not that high, but the IOD correlation is high. And then there are debates about whether it's the IOD plus El Nino that amplifies the anomalies over East Africa, like Kenya and so on. And there are also non-stationarities of these correlations. So if you look at 10-year sliding correlations between July, August, September dipole mode index versus OND rain, July, August, September Nino 3.4 and OND rain on Kenya, and so on, there are times when the correlation collapses and even switches sign. So there is some non-stationarity there as well. Considering how infrequent this IOD event is, one has to be careful about whether IOD is just adding to the ENSO signal or whether it's adding some independent information. For example, the IOD relation with the Indian monsoon is also not so robust. So the book goes through some arguments about how the waves were also involved in the IOD of the 97-98 episode. So we are looking here again going from January to January of 97 into July of 98, and you can see these waves in the sea surface height anomalies, which typically are the best to track waves. So this is the longitude of the Indian Ocean, and this is looking at the southern part where the thermocline ridge is, and arguing for how the off-equatorial Rossby waves are converting into coastal Kelvin waves and then equatorial Kelvin waves, and how the much further south signal is coming in. But at any time you look at the Indian Ocean, you always have Rossby waves here, because there is wind stress curl that is pumping the thermocline and releasing Rossby waves. So whether these episodic events here are affected by this, and whether they are triggered by this or amplified by this and so on, are all not very clearly answered. But nonetheless, individual events like this have to be interpreted carefully, and this is just another depiction of how the waves can be tracked to argue for the initiation of the 97 IOD event. I wouldn't be too I would be careful about looking at broader literature about how IOD actually works and what are the latest ideas. For example, there are papers arguing that there is also a recharge-discharge happening in the Indian Ocean associated with the IOD. But you have to remember the trade winds are strong only in the southern hemisphere, south of about 5 to 10 south. In the north, you have these changing wind directions from southwesterly to northeasterly, and the equatorial upwelling is more on the western side. Thermocline is tilted from west to east. East Indian Ocean is part of the Indo-Pacific warm pool, and so on. So there are all these differences. So the fitting of ideas from ENSO into the Indian Ocean is tempting, and sometimes done with limited data, reanalysis products, and so on. And then there are arguments about whether Indian Ocean dipole is also predictable and so on. But pretty much everything is an open question right now. But it's clear that every so often this event gets very strong, and then there is clearly a Bjerknes feedback, but there may be weaker events which are related to El Nino related fluxes. And then I will show another construct called the Indo-Pacific tripole, which gives you a slightly different sense of how to place IOD maybe in the Walker circulation of the Indian and the Pacific Oceans. Okay, so lots of open questions, but this is definitely an interesting and coupled phenomenon which is when it is in its strong phase.